Galactic Cannibalism, the Milky Way's appetite. The Milky Way isn't just a majestic spiral galaxy, it's also a cosmic predator with a history of consuming smaller galaxies. This process, called galactic cannibalism, is how our galaxy grows and evolves over time. When smaller galaxies stray too close, the Milky Way's powerful gravity begins to pull them apart, gradually assimilating their stars, gas, and dark matter into its own structure. It might sound destructive, but this process is a key driver of galaxy formation and evolution. One of the most famous examples of this is the Sagittarius Dwarf Galaxy, which is currently being devoured by the Milky Way. Streams of stars from this galaxy, known as tidal tails, are now stretched out across the sky, forming a bridge of stellar material that wraps around our galaxy. These stars, originally part of the dwarf galaxy, are becoming part of the Milky Way's outer halo, blending seamlessly into its massive structure. But Sagittarius isn't the only galaxy to face this fate. Scientists have discovered that the Milky Way has absorbed numerous dwarf galaxies over billions of years. Some of these mergers happened so long ago that the evidence has been completely incorporated into the Milky Way, while others, like the Gaia-Enceladus merger, have left behind distinct populations of stars with unique compositions and motions. Each act of galactic cannibalism leaves subtle traces that astronomers can study to uncover the Milky Way's growth history. This process isn't unique to the Milky Way, it's a natural part of how galaxies evolve in the universe. As galaxies collide and merge, they create stunning displays of cosmic interaction, from starbursts to streams of gas and dark matter. For the Milky Way, this appetite for smaller galaxies has been essential to its development, helping it grow into the massive, dynamic structure we see today. By studying galactic cannibalism, we learn not only about the Milky Way's past but also about the dynamic forces shaping galaxies across the cosmos.